Scratch the city's glamorous skin and you find places where a rusting sheet of corrugated iron is a luxury. The sprawling slums or favelas are symptomatic of a wider housing crisis in Brazil. Unable to afford even the most basic building materials, most of this country's 150 million residents are destined to spend their lives in makeshift homes. Like most large cities, the more affluent part of town has a skeleton made of steel. Metal girders are the ligaments that keep its large buildings together, the bones that hold its skyscrapers aloft. Steel reinforcement can be the difference between a temporary or a permanent home. Now a grass that, under the right conditions, will grow an incredible 5 centimetres an hour, about that much in a day, is being considered to replace steel in concrete buildings. And it's one of the most widely used materials on Earth, bamboo. A quarter of the world's population has over 1,300 uses for this remarkable plant. And as a cheap, durable building material, it's unparalleled. But although bamboo is an integral part of the Brazilian landscape, it's usually dismissed here as a weed and a nuisance, and rarely used in construction.
If Brazil was discovered by the Chinese, I'm sure the use of bamboo was very common and popular, most probably.
When asked to develop low-cost building materials, Dr. Ghavami and a team of engineers from the Catholic University combed Rio's botanic gardens for an answer.
It grows very fast, and we marked this bamboo in February '91, and it has grown to almost 25 meters within 2 months.
After examining the physical characteristics of hundreds of species of bamboo, a short list of 7 were put to the test. And this ancient building material proved to have some very modern mechanical properties indeed. The beauty of bamboo is that it's not only very light, but it's very rigid. The 9 of us weigh well over half a tonne, and we're on a 6-metre span. But the major attraction for builders is its tensile strength, which is equal to steel. That slender thread over there can hold more than a small car. A concrete slab has a high compression strength, but low tensile strength. It's 10 times stronger when pressure is put on it than when it's pulled. Steel rods help reinforce it by taking up the tension. Dr. Ghavami's team believed bamboo would do just as good a job, except for one problem. The plants tend to absorb moisture. Periodic swelling and shrinking could crack the concrete, so bamboo poles were carefully cured and treated with a mixture of sand and bitumen to help them bond with the concrete. A steel and concrete slab of this dimension will take a load of 4 tonnes. Well, the engineers here calculated that a bamboo version would take a load of 4.5 tonnes. But when they applied the force, something unexpected and very exciting happened. First 5 tonnes, then 7 tonnes, and they went up to 9.5 tonnes before the slab broke. In fact, it proved to be twice as strong as steel. And the reason for that was this. Nature had designed the perfect connector. This diaphragm proved to be as good as, if not better, than the metal shear connector designed to hold concrete and steel together. As well as finding its way into concrete slabs, bamboo may well stand alone, a low-cost substitute for steel beam space structures. An easy way to cover large areas with next to no building materials, bamboo space structures are a light and airy solution to Brazil's accommodation shortage. The treated bamboo poles clip together with specially designed joints, and very little technical knowledge is required. In next to no time, a building will take shape from homegrown materials. No one has suggested yet that bamboo would replace steel in high-rise buildings. But for countries like Brazil, Professor Ghavami's work has proved that bamboo would be a great help where there is a great need for cheaper housing. If nothing else, they would have the strongest grass houses in the world.